Hello, here is the review for the quiz over trig identities. The key to this quiz, use the identities. Okay, hopefully everybody's good. When you don't have any identity that you can use, and the directions say simplify or verify, then what you would like to do is try to get everything in sine and cosine. So we don't have anything squared. There's no identities here. So we're going to have to just put everything in sine and cosine. So it's already kind of that way. So for the first problem, we're going to start by just leaving that cosine plus sine. Now, tangent is being multiplied. Keep the multiplication. Tangent switches to sine x over cosine x. If it helps to put all these others over 1, then do so. No, you cannot cross off the cosines. People who like to cross stuff off, because the first cosine is not attached to the second cosine in the denominator. They are separated by the plus sign. We are adding them. So we need to get a common denominator. This second fraction, if we put it back together now, it's not going to look the same. The second fraction is sine squared cosine. So our common denominator, our only denominator, is cosine. So that means the first problem is going to, the first fraction rather, is going to have to be multiplied by the cosine, top and bottom. So now we have cosine squared x over cosine x. When you put this together and you write it like a single fraction, then you use the denominator once, and the numerator is cosine squared x plus sine squared x. That is an identity. It's 1. And more of a cosine, of course, is secant. Now, these first two problems that the directions say simplify, there are 2 of these on the quiz. That's what my little green 2 is here. This one, hello. And we have 1 of the 2 are multiple choice. 2 of them, one's multiple choice. For number 2, 1 minus sine squared. This is a thing. This is an identity. Remember, it's sine squared plus cosine squared equals 1. When you subtract the sine squared from both sides, you get 1 minus sine squared on this side, and this side is cosine squared. So 1 minus sine squared is coming out. In its place is going cosine squared theta. I'm just going to keep track of that by putting it over 1. Now, this second fraction is about to get a little crazy. Second fraction, nothing squared, can't use the identity. So we're going to put everything in terms of sine and cosine. So sine is sine theta over 1. Cotangent is cosine theta over sine. And, of course, the secant is 1 over cosine. Now, since these 2 fractions are being multiplied together, these 2 right here, I'm not cross-multiplying. I'm reducing. It's like multiplying by 2 and dividing by 2. They undo each other. So that's gone. So now I got to kind of figure out what I have here. I feel like this is kind of a mess. I'm going to rewrite this a little bit. I might also need a little more room. How's my black background treating me? Not so good. All right, so this is going to be cosine squared theta over 1 minus. Let's just look what we have. It looks like we have cosine over 1, cosine theta over 1 over 1 over cosine theta. So you can take this second fraction, this one, and you can flip it over, 1 over cosine, and multiply. Or you can take the top and the bottom. Oh, sorry. When I flipped it over, I did a very bad job of flipping it over. When you flip it over, it's cosine theta over 1. Or you can see you would take the very top and very bottom. That gives you cosine squared. And these 2 give you 1. Either way, we get cosine squared over 1. But don't forget about this one. This is still here. So to clean this up a little bit, the first part of the question is cosine squared theta minus the second part of the question, which is cosine squared theta, and that is a 0. In the verifying section, one question, just one. You pick one side and work down that one side, you get it to match the other side. Excuse me. I'm going to pick this left-hand side. I'm going to make this a single fraction by getting a common denominator. A common denominator means you need one of each factor that's unique. So all my factors, 1 minus the cosine of x and 1 plus the cosine of x. I'm not cross-multiplying. I'm just making the numerators catch up. So this particular fraction, this first fraction, in order to make this denominator look like the one we just completed, has to be multiplied by 1 minus cosine x. That's going to be easy to multiply by 1. This is a negative 1 for the second fraction, and we have to make the denominator match, so we're missing a 1 plus cosine x. Again, the denominator is in charge. The first one, we multiply it by 1. We are left with 1 minus cosine x. Distributing this negative 1 to my second part of the numerator is going to be a negative 1 minus cosine x. Your signs are critical. On the top, we have 1 minus 1. That's 0. Also, when we combine like terms, we have negative 2 cosine x. The denominator. When you multiply these together, if you use FOIL, you would get, you can see it's a difference of 2 squares. So we're going to have 1 minus cosine plus cosine. That's gone. I'm doing this for those of you that can't see that it's the difference of 2 squares. And then the last two is minus cosine squared. These are gone. This is 1 minus cosine squared x, because the minus and the plus are gone. This is really 1 minus cosine squared is sine squared. Now keep one eye on the answer. Don't forget about the answer. We're not there yet. I got the negative 2, so that's good. Let's think about how we can force this answer right here. This is what we're looking at. This is our goal. All right, so don't lose track of it. I'm going to keep the negative 2. Cotangent. Cotangent is cosine over sine. I still have one of my sines left, times 1 over sine. That's basically what I have. The numerator is like this, negative 2 times cosine times 1. I still have that. I have negative 2 times cosine times 1. The denominator is sine squared, which is 1 times sine squared. I have 1 times sine times sine. So if we think this through, we get negative 2. Cosine over sine is cotangent, and 1 over sine is cosecant. And that's finished. Number 4. No formulas. 0 identities can be used here. So that means we're going to put everything in sine and cosine. I'm going to work this right-hand side. 1 plus sine x over cosine x. Oh, on top of course, my denominator. Plus sine, don't forget about that. Now, the the numerator needs to be added together, so we need a common denominator. So I'm going to turn my 1 into cosine x over cosine x because the denominator should be a cosine x. So my common denominator is cosine x. Across the top, I have cosine x plus sine x. The denominator, sine x plus cosine x over 1. So again, you can take that denominator and flip it over and multiply, or you can do this thing where you do cosine x plus sine x, and then the denominator is these two. Cosine x outside, sine x plus cosine x in parentheses. Don't multiply it out because your factors, they cancel. This whole thing is gone. This is a 1. I have 1 over cosine x, and keep an eye on the answer. 1 over cosine of x is the secant of x. Done. Made it match. Now, in this next section, when we do numbers, there will not be tangent for sum or difference. You can see we have the tangent of 2 theta in that number 6. That tangent formula for 2 theta, that's a pretty good one. You can usually put it in your calculator. But we will not have tangent for sum or difference identity. So that first review sheet from Monday night had some tangents on it. It won't be like that. It won't be anything crazy. So sum or difference means you have to add or subtract to get to 15. The goal is the 15. So I'm going to subtract, and I'm going to go 45 minus 30, because 45 minus 30 is 15, and of course it's sine. Look at the formula sheet. It tells you exactly what to do. Sine of the first angle times cosine of the second angle. Now for the signs, the plus or minus sign, the signs match. So if that's a minus, this is a minus. And then the formula is cosine, first angle, sine, second angle. You're going to take out the words. A lot of you are leaving the words. Get rid of the words. All of this is an answer. The sine of 45 is radical 2 over 2. All of it's gone. Cosine of 30, radical 3 over 2. Minus cosine of 45, radical 2 over 2. Sine of 30 is 1/2. You are going to multiply these two together and then these two together. So straight across the top, straight and straight across the top. So this is going to be radical 6 over 4 minus straight across the top, radical 2 over 4. Now the idea is that you're so good at these fractions that you can write it as a single fraction. You've got a common denominator of 4, you write that once. And across the top we have radical 6 minus radical 2. It's simplified, it's finished. Now for number 6, there's 2 questions, and you can see over here to the right side I've written 2 questions like 6 and 7. So 6 and 7 are both double angle formulas. And there's 2 of them. I think one of them might even be multiple choice, but there's 2 of them. So cosine of theta is 4 over 5, and it's in quadrant 4. Whoops, sorry about that, a little slippery. So we're in quadrant 4. So draw your triangle in quadrant 4. Cosine is adjacent over hypotenuse. Good old SOHCAHTOA. This is always your angle right up here, snuggled up in the 0, 0. Adjacent 4, hypotenuse 5. Pythagorean theorem is your next best friend right here. If you don't know the answer, remember it equals the hypotenuse squared. So 4 squared plus x squared equals 5 squared. 16 plus x squared equals 25. Subtract the 16. We get x squared equals 9. And then, of course, that means x equals 3. Tangent of 2 theta formula says 2, I'm going to put it over 1, times the tangent of theta. All scholars take, tangent's negative. So negative 4/3. Oh, sorry, I'm upside down. Negative 3/4. I'm pointing to it, but it's not, I'm saying it wrong. So negative opposite over adjacent. The denominator, 1 minus negative 3/4 squared. This entire thing can be put into your calculator. I would advise not doing it that way. Put the top in the calculator, get a fraction, write it down. Put the bottom in the calculator, get a fraction, write it down, and then deal with your fraction, one on top of the other. So if we multiply these fractions on top, we get negative 6 over 4. Yes, that reduces, but so what? So your calculator maybe gives you 3 over 2. It's the same thing. The denominator. When you square this 3, you get 9. When you square the 4, you get 16. So this is going to be 16 over 16 minus 9 over 16. This is 7 over 16. Use the calculator. There's no reason to do what I'm doing. Then when you put it in the calculator, negative 6/4, close that, divided by 7/16. You get negative 24 over 7. This is the same question from the Pick 5 paper. So if you got that wrong, there it is. Number 7, again, double angle, cosine 2 theta. This means you get to pick whichever one you want. Pick one. It doesn't matter. So for number 7, let's draw where we are, because where we are controls plus or minus signs. So between 180 and 270. So we're here in the third quadrant. Cotangent. I don't know what cotangent is, but tangent, stop doing 1 over tangent. Tangent is opposite over adjacent, which means cotangent is adjacent over opposite. So that means it's adjacent is the 3 and the opposite is the 2. Pythagorean theorem. 2 squared plus 3 squared equals x squared. 13 square root radical 13. All scholars take calculus. All right, so we know that the tangent's positive there. I don't even know if we need the tangent, but everything else is negative. I like, because of the radical, I like the cosine squared minus the sine squared. That's the formula. That's from the formula sheet. That's your identity. Cosine is going to be negative. Cosine is negative, so 3 over radical 13. Negative 3 over radical 13 squared minus sine squared. Sine is opposite, but it's also negative. Negative 2 over radical 13. Squaring fractions is easy. You square the top. Negative 3 squared is a 9. Square the bottom. That radical squared turns into plain old 13. Top squared is a positive 4. Bottom squared is 13. Whoa, not the radical. I don't have any eraser, so I'm just sorry. So that's what we have. That's it. We have a common denominator already. 9 minus 4 is 5. The denominator is 13. There it is. Half angle identity of pi over 8. You don't like radians? Don't do it in radians. All right, so pi over 8. Pi over 8 times. I'm getting rid of the radian. 180 over pi. Gone, gone, bye-bye. 180 divided by 8 is... I have no idea. 180 divided by 8 is 45. I'm sorry. Make sure you know what you're doing. So now what we're going to do is use the 45. All right, so we're going to do the sine of 45 over 2. This must not be 45. This must be 22.5. Okay, that's better. Sorry. 22.5. Ignore this. Because 45 over 2 is equal to 22.5. Because we're using half angle identities, you basically take your angle and you multiply by 2. That's how you know it's 45. The formula, if you recall, is the giant radical. Giant radical. 1 minus cosine of 45 over 2. The giant radical is a problem. So I'm going to immediately start writing it without the giant radical. There's one problem like this on the quiz, by the way. Square root of 1 minus, the cosine of 45, that's radical 2 over 2. On top of this guy. I never took the square root. That radical sign is still stuck to him. I haven't taken the square root of anything. I took the cosine of 45 and wrote that in there. So, my laziness, I'm just going to go 2 over 2. Again, as I go, I'm not just simplifying this. I'm also trying to figure out where the radical signs are. So there's still a radical sign. There's a radical sign here, but the radical sign is over the top, which is the big one, 2 minus radical 2. This denominator still, even though it's a common denominator, still has a radical in it. This one is this one, radical 2. And I'm just going to put it over 1, because you can put any fraction over 1. Invert and multiply, or very top and very bottom, radical 2 minus radical 2 underneath there. Yes, this radical sign goes over the whole thing. The denominator is these two. Radical 2 times radical 2 is a plain old 2. Okay. There we go. Solving. There's one problem like 9 and 10. And there's one problem like 11 and 12. I was trying to figure out what I meant by that. 11 and 12 go together because they each have a number in front of the x. That's not true for 9 and 10. Now, they have different numbers, and you're going to do these differently, but they each have a coefficient in front of the x. The 2, you have a formula for. We'll get to number 12. The 3, you don't have a formula for. We'll get to that one too. Let's take a look at number 9. 2 sine x. That's not a formula. The sine of 2x is a formula. But 2 sine x, not a formula. I'd like to get all the numbers on one side and all the words on the other. I think that's smart, right? Because that's how it ends up. It ends up tangent equals 5, or, sine equals radical 3 over 2, whatever you happen to get. So I'm going to divide both sides by 2. Radical 2 over 2 tangent equals sine. Now this is going to look funny. Divide both sides by tangent. And now I have the numbers on one side. I like radical 2 over 2. I know that. That looks familiar to me. That's some sort of unit circle value. So I'm hoping to keep that. And the right-hand side is sine over 1. Tangent now. Tangent's in my denominator. Tangent is sine over cosine. I basically took my words and just exploded them out. Radical 2 over 2, still going strong. Top and bottom. Sine x, cosine x. These two, denominator. Sine x. This is a fraction that has no adding and subtracting in it, so you can reduce the fraction top to bottom. So now the question is, radical 2 over 2 equals the cosine of x. So what angle, or angles, in radians, look at your interval, has a cosine of radical 2 over 2? Well, that's pi over 4. And it's in the fourth quadrant too, which is 7 pi over 4. On to number 10. Cosine squared. Cosine squared is a thing. I'm going to take it out. I feel like this might be risky because there's a cosine in both, but I'm still going to take it out because I have a feeling this cosine is going to be gone. So if we take this cosine over 1. Tangent is sine over cosine. Since you're multiplying those, you can reduce it top to bottom. So now we just have sine. So I don't want this cosine. This cosine squared is going to mess me up. I got to make it in the same word. So the minus 2 is still there. And cosine squared is 1 minus sine squared. I'm going to bring this one over. I'm going to move this over. Plus 1 equals 0. You know you're going to have to factor it. You might as well get a set equal to 0. Sine of x equals, distribute. Now when you distribute, there's everything, the negative, the 2, all of it. Negative 2 plus 2, why do I have that equal sign there? Where'd that come from? This is not here, sorry. Plus 2 sine squared x plus 1 equals 0. Put it in order. wait a minute. I think we can add some things. So we've got this. This doesn't add up with anything. 2 sine squared x. Sine x. That has nothing else in common, so plus sine x. Negative 2 plus 1. That's a minus 1. Now I'm ready to factor. To get to 2 sine squared, I need 2 sine x, sine x. In order to multiply to get to 1, this is easy. That's 1 times 1. Now, the signs, the plus or minus signs. Outside is the oi part of FOIL. Outside is a 2, inside is a 1. Outside is a 2, inside is a 1. In order to get a plus in the middle, I need a plus 2. And the 2 came from this long one. So the plus goes out here, and the minus goes in here. So now I have 2 sine x minus 1 equals 0. And the sine of x plus 1 equals 0. So the sine of x equals negative 1. And the sine of x equals 1/2. This one's in degrees for one rotation. Sine is positive in the first, I got it right here, first and second quadrant, so that's 30 degrees, and 180 minus 30, so that's 150. Sine is negative, negative 1, so that's going to be down here at 270. If you put that in your calculator, it gives you negative 90. You can't have negative 90. The interval says the smallest one is 0. Number 11, the easiest kind we've got. This is a weird number, a 3. No identity for a 3. So that means you got to take your interval and multiply by 3. So now we're going from 0 to 720. Yikes. That's not right. My multiplication is messed up. Sorry. 720. Oh, it won't erase. Okay, ignore that. So we're going from 0 to 1080. That's better. There it is. Multiply by 3, not by 2. Multiply by 3. So now I'm going to go, okay, I'm going to take this out. I took care of the 3. So now I'm saying, okay, the tangent of something equals 1. The tangent equals 1 in degrees in a lot of spots. All scholars take calculus. So here and here. So that's 45 plus 180, 225, plus 180, 405, plus 180. This is where knowing the plus pi k, plus 180k, can really be helpful. Plus 180 is 585. Plus 180 is 765. Plus 180 is 945. Plus 180, too big. Now, to fix this, you have to go back and divide all of these numbers by what we multiplied by in the first step. I wasn't so good at multiplying, but it was a 3. And then you write down the answers. So they are 15 degrees, 75 degrees, 135, 195, 255, I think that's probably 225. I feel like I messed up somewhere. And 315. I feel like that looks weird. Because it's supposed to be 225. No, we don't have 45. So this is right. This is 255 right here. Sorry. 255. A lot of times when you divide, you get the answers back. Like, for example, we may have gotten a 45-degree angle in here because we know that 45 is really the right answer. As it turned out, we didn't get that. But a lot of times you get the original angles back, and I was sort of anticipating that happening, and then the arithmetic didn't work. So it's not true. It's not right. It's 255. Okay. Now for this one, I feel like we have a real situation because the sine of 2x is a real thing. But the sine squared of 2x, that's not anything. So because it's a combination of sine squared means we cannot use the sign. You cannot use the sign of 2x identities. Do not take that sign of 2x identity and square it. Please do not square it. We good? So we're going to start by multiplying by 2. 0 to 720. See, there's my 720. I knew I had it somewhere. And let's just start. So I'm going to try to get all the numbers together. Remember, my sign of 2x is really not 2x anymore, because I just took care of it. So now I essentially have 4 sine squared, I'm going to call it theta, equals 1. Divide both sides by 4. Sine squared theta equals 1/4. Sine squared I don't want, square root. So I get sine of theta equals plus or minus 1/2. This is a lot of numbers because the sign is positive and negative in 4 spots. All scholars is positive or negative in all 4 quadrants. So this is a 30-degree angle we're dealing with. So 30, 150, 210, 330. Now, to get to the second rotation, you can take the 30 and add the 360. 390, oops, can't write too good. 150 plus 360, 510. You don't have to do it this way, but if you're stuck, it works out pretty good. This is 570, and then this one is 690. Then, of course, as you know, we go back and divide everything by the 2. It's a 2. It's not a weird number, it's just a 2. So we got 15, 75, 105. I can divide by 2. Maybe. 165. I'm on the 390. That's going to be 195. 510, 255. 570 divided by 2 is 285 degrees. And 690 divided by 2 is 345 degrees. I sure hope you enjoyed this as much as I did. And good luck on your quiz. It's pretty good. It's pretty easy. It's shorter than this. So, and there's 2 multiple choice. Remember that. Bye.